Good afternoon.
Good afternoon, doctor.
Good afternoon. Can you hear me?
Yeah.
Okay, thank you.
You got class now soon after the program?
Pardon?
You got class now at 4:15?
Yeah. Yes, 4:15, yes.
So exactly 1 hour enough.
What? Again, pardon?
Exactly 1 hour enough.
Yeah, plus minus I think it's okay. I already informed my students to start at 4:30. 4:30. So before 4:30, I need to end the teaching. Yeah.
No problem.
Yes, no worries.
Doctor?
Yes.
Yes.
இதக்கார வாங்கப்பா மீட்டிங்ல இருக்கிறாங்க.
Shall we start?
Yes. So,
Madam,
sorry.
ma'am. First let us
Yeah,
go to
yeah. Okay.
welcome address.
Shall I start now, Girija madam?
Yes.
Yeah.
Welcome, Dr. Ho. Welcome address.
Okay. So
Good
thank
morning
you.
to
So,
all.
You can proceed, no? Ma'am.
Hello, shall I start now?
Yeah.
Yeah. Okay, thank you. Good afternoon to all. Myself, Uma, Professor and Head, Department of Science and Humanities, Hindustan College of Engineering and Technology, Uttaka.
Yes. Your mic off. No voice.
Approved by AICTE, Department of Science and Humanities. I welcome all of you joining us for the second day of our International Faculty Development Program on Prominence of Mathematics in Diverse Sectors. Today, it is to be presented by Dr. Ho Ming Hong from Asia Pacific University, Technology and Innovation, Malaysia. He is going to present on analyzing time series data using R. I am happy to note the active participants, and without much delay, we will turn the time over to Dr. K.V. Girija for welcome address. Thank you.
okay. So thank you so much.
Introduction about Dr. Ho Ming
Okay.
Dr. Ho Ming completed his PhD in the year 2014 and currently a senior lecturer in Asia Pacific University of Technology and Innovation, Malaysia. His research activities mainly on data analysis such as regression modeling, time series and forecasting, survival analysis, missing data analysis, and with a growing interest in machine learning now. Today, he has published more than 10 journal articles related to data analytics. He conducted workshops on SPSS and R software and also on developing analytical skills in decision making relational to operations research. Now, it is my pleasure to welcome Dr. Ho to deliver his presentation. Welcome, sir.
Okay, thank you so much, Associate Prof. Dr. Girija and all the fellow students here. Before I start, let me try to share the slides. Okay. Try. No. Window. Yeah. So can everyone see the slide?
Yeah.
Yes, okay.
Yes.
So I will turn to the begin. Okay, so thank you so much for the invitation, and it's my pleasure to be here to share something on data analysis. Okay, to all the participants, including lecturers and the students here. So my name is Dr. Hong. He's a senior lecturer and program leader of in Asia Pacific University of Technology and Innovations in Malaysia. So my area of expertise basically focus on data analysis, okay, which has been applied a lot of data analysis techniques in different disciplines. So including my PhD was about hydrology. So now also started to apply a lot of different skills in analysis, in actual science, even in finance data set and so on. So why I'm interested in time series data, even though this is not my PhD topic. My PhD basically is on missing data analysis, but I started to grow my interest in data in time series because I feel like every one of us like to do forecasting. Okay, so I still remember when I was still small, I always like to forecast what would be the weather today. So based on the rain condition yesterday. So because I want to go out to play with my neighbors, so I always look at the weather. Okay, let's say yesterday was raining, so most likely it's actually today will be raining as well. So let's say yesterday was a sunny day, 1 day or 2 days ago was sunny day as well. So most likely today is sunny day as well, so that I can go out with my friends. Okay, so in that time, in these days, actually, we have started to apply some concept of forecasting because you always refer back what happened before, like 1 day, 2 days, 3 days, 4 days before, in order to predict what happened today. That's actually why time series analysis is very interesting. Okay, and this kind of time series analysis, basically you have started to learn since small. I think these are the forecasting game that being considered as game that you have started to learn since primary school or maybe the high level and so on. So for example, we like to predict the next number in the pattern. Okay, so when we want to do the prediction, so basically what we try to do is we were looking at how's the behavior or the data of the pattern of the data set before. For example, in the part A, 3.7, 3.7, 3.7, 3.7, 3.7. So let's say imagine this is day 1, day 2, day 3, day 4, and day 5. Up to day 5, all the values given is 3.7. So most likely the next day also 3.7. Okay, how we guess this is 3.7? Because the data before all says that 3.7. So therefore, today definitely is 3.7. So we're looking at the part B, 2.5, 4.5, 6.5, 8.5, 10.5. Okay, I think these are the common questions for the primary school student. Okay, we're looking at the data set in the past 5 days. Okay, so you found that the increment from one period to the next period is actually increased by 2 units. 2 units increased from one period to the next period. So from here to here, also 2 units increase. Here to here, 2 units increase. Here also another 2 more units increase. So therefore, I will predict the next value is 12.5. Why I say this 12.5? Because the data set before explaining that there is a trend component present and each unit that increase is by 2 units. So therefore, I am able to expect to predict the next value is 12.5. And the last one also 5.0, 7.5, 6.0, 4.5, 7.0, 9.5, 8.0, 6.5. May I know what would be the next value? I count 5, 5, 4, 3, 2, 1. So the answer is 9.0. Okay, so imagine this is a data set that you've been observed previously. So there are 8 data sets been observed. So what you can see from day 1, day 2, day 4, and day 4. So basically they follow a pattern. What kinds of pattern that I mentioned here is, this is 5.0, then we're going up to 7.0, then going down to 6.0, then going down again to 4.5. Okay, so imagine this is quarterly data, quarter 1, quarter 2, quarter 3, quarter 4. So up to quarter 4, the values drop to 4.5. But when it comes to the next year, for example, next year, so the data have increased to 7.0, sorry, 9.5, 8.0, and then going down to 6.5 again. So if you compare the first 4 and also the last 4, you have found that the pattern are exactly the same. We're going up to the maximum, then going down to minimum. So the next four is also going up to maximum 9.5, then going down to 6.5. And you found that when you compare quarter by quarter, for example, this quarter and this quarter, is actually is 2 units increase. Same for quarter 2, 2 units increase. Quarter 3, 2 units increase. Quarter 4, between quarter 4, also 2 units increase. So imagine this is actually is quarter 1 in the next year, in the third year. So therefore, since quarter for quarter, so the increment is 2 units, therefore the next value is 9.0. Okay, so definitely you may have your own way to interpret. So, but when I try to look at this and I try to relate to time series, we have found that this 8 data set consists of 2 time series components. So I explain briefly what is actually time series component. Okay, time series data, basically you were able to know what is time series. Time series is basically when looking at the explanation here is the time series is a set of the values which occur sequentially in time. So that's why I always mention like day 1, day 2, or first hour, second hour, or quarter 1, quarter 2, because we would like to see how the changes of sales change over the time. So when I say change over time, then your x-axis in this kind of time series plot will be in time. So for example, the right-hand side one, this is the time series plot, right? Because you're looking at the data set, movement of the data set. Okay, so you found that the same pattern repeated every 12 days or something, 12 months probably. So 12 period. So you get the same pattern again. And in time series plot, normally we present in a line graph. It's a line graph. So, but for the left-hand side, this is also a line graph. Your y-axis is also about the sales. However, your x-axis is not referring to the time. Okay, but this is actually is the number of staff. Unless this data set, this x-axis change to time component. So for example, weekly data, quarterly data, monthly data, daily data, or hourly data, then this data set will become a time series data set. Okay. Otherwise, when you're looking at this graph with sales and number of staff, this data set which is trying to tell us that there is a strong relationship between the staff and also sales, and we're also able to evaluate the house performance between store A and store B. But eventually, this is not a time series data because you are not looking at the sales performance change over the time. Meanwhile, for this one, this is a time series data. Right, time series data. We focus here is actually on time series because time series all changing over time. So it's very challenging to understand how the behavior of the data set, and eventually we collect all the data set information given by the historical data to produce the forecast for the next period. So why we want to do some time series analysis? As I say, we want to first to describe the data set first, to describe what happened in the past. Increasing, decreasing, same pattern repeated every certain period of time or others. So we want to describe the data set. So once this one has been successful, once you're able to describe, okay, this data set is actually consists of time component. Well, then we can use a suitable model to do for forecasting. So our aim, our final focus is actually on the forecasting because when people talking about time series analysis, so they always relate to forecasting, improve the performance. So that is actually why we want to do the time series analysis, because if you're able to produce a very good forecast to the company, then the marketing team and also customer service, all the department related will know how do we plan the strategies appropriately. If you if let's say you have underestimated the observed value, for example, you use a wrong model, so therefore your values that you calculated always lower than what we observed, that will actually affect the profit of the company. Same goes to when you have consistently overestimate. Overestimate means that because you're looking at your value, then only we produce the production. Okay, so but when your value is always overestimate the observed value, overproduction basically will also eat the company. So therefore, we need to always keep changing improvements, no bias value, always able to follow the actual pattern of the data set and able to use to improve the strategies of the company to increase their profit. So that's why we want to do some time series analysis. Okay, so always I mentioned like how to describe the time series data actually all relate to the time series component present in data set. When you have a longer period of data set, such as more than 4 years, 5 years, 10 years, so basically all this data set is built by the 4 components. Actually have 4, but in this one only 3 components. So the first component, which calls as seasonality. Seasonality, for example, like the sales of the product is always the highest in Q2. Why? Because of some celebration. That's why the sales is the highest in Q2. Same when we try to project to next year, the following year, and so on. So the sales is always the highest. So that can be interpreted as the similar pattern actually repeated every 4 quarters. That is the examples of seasonality. Trend component is basically is a quite common component present in all the data set that you have, because most likely all the sales or the demand of the product will increase over the time. So that indicates that there is an increasing trend. It also can be in the negative direction, so it means that decreasing trend or downward trend, which is also possible in one data set. Another one is random variation, or some they also call this as the irregular variation. It's some noise which is due to the unpredictable event, such as unpredictable natural disaster happens in this period. So therefore, there's a drop of the sales. However, the duration of this random variation is very short. So probably just 1 quarter or maybe 2 quarters. After this event, so the business, the demand will back to normal and follow the pattern that we predict earlier. So that noise, that's random variation, there's unpredictable event, we call it as irregular variation, something that you cannot avoid because of some unpredictable event happen. So these are the time series components that might present in one time series data, and in one time series data, it is possible to have more than one time series component. In most of the economic data, business data, so most of the time they consist of both trend and seasonality. Okay, both trend and seasonality present in the data set, and some maybe consist of random variation as well. So 3 components present in the same time series plot. So the challenging part is actually how do we know which model is the best? Okay, how do we determine whether to use this model or use that model or other models? This all depends on what you can observe based on the time series data that you have. Okay. Here I share with you some of the guidelines that you can refer. Actually, there's a lot of time series model that can be considered. So, but the time series process will basically first you have to look at the data set. Okay, look at the data set. And we always try to project, or we would like to visualize it using a time series plot, like what we discussed just now. So the line graph to show that whether there's an increment or decrement or seasonality present. So the first step is basically to construct a plot from the data set that you generated. Then only we try to select some of the models based on your observation. It all depends on the pattern that you've been observed based on the plot, which can actually be divided into 3 groups. Whether there's no trend and seasonality, both trend and seasonality not present in your data set, or only consists of linear trend model but no seasonal pattern, or both both trend and seasonal pattern present in your data set. So these are the few models that can consider, but actually there's a lot of models, okay, such as no trend and seasonality. So you can consider to use simple exponential smoothing. Or even you also can use weighted moving average. I think this is a common method that time series data will use, time series analysts will use, moving average. Okay, let's say for those who have trend component, okay, trend component only. So keep on increasing or decreasing over time. So you can consider to use a Hawk's method, or there's one model called ARIMA, auto-regressive integrated moving average. Or let's say you have both trend and seasonality, so you can consider to use Hawk's window. Or you can use the same model, auto-regressive integrated moving average. So this model is actually quite powerful and can use for non-seasonal and seasonal data. So in time series process, basically we'll never just choose one model. So we try to choose more time series model, because you never know this model could fit well or not. So based on your observation, or you will say, oh, Hawk's method is the best. But who knows? Maybe Hawk's ARIMA model fits better, or some other model could fit better to you. We want you to propose more than one. Since you need to produce for next period, will be chosen as the best model. Okay, so the one with the minimum error would be the best model, because they're able to generate the forecast value closest to the observed value. So it means that this model is powerful and can use for forecasting. That's actually the whole process. The graph, choose method, and then evaluate. That's actually standard procedure for the time series process. Okay, let's look at the one examples here. This data set can be taken from the Department of Statistics in Malaysia, which is about the average growth of population in Malaysia from 1970 to 2017. So they have no data set after that. So that's why I only have data up to 2017 only. Okay, so as remember, the first process would be, once you get the data set, then you would like to present it in a time series plot. Okay, so based on the time series plot here, actually you can see that the growth of population is actually decreasing over time. Even though there are some period of time that is increasing, but in general, so the population, the growth of population is decreasing. So we can conclude that there is a downward trend present in your data set. Downward trend means that the population decreases over time. Okay, not only this component, we also have another one which is called random variation, because there's a lot of noise happens here in this data set. Okay, so there's a random variation or irregular variation, and also trend component present in your data set. Okay, so these two components present in your data set. So once we have identified, this data set only consists of trend and random variation, okay, no seasonal variation. Therefore, you are not going to choose this model. You will say no with this one and also this one. You will say no to both, because this data set consists of trend ARIMA model. Probably I will also choose this one, see maybe this model could be fit that, because simple exponential smoothing, simple, not single, simple exponential smoothing, typo error. Okay, simple exponential smoothing actually is one of the model can work well with if there is a trend component present. What you need to do, you just need to increase one of the parameters in your data set, and then in the formula in order to produce the best forecast. So in that case, I will choose this three: Hawk's method, ARIMA, and also trying to use one simple exponential smoothing as the comparison. Okay, so I will choose these three: Hawk's method, ARIMA, and also the simple exponential smoothing. But before I want to evaluate them, right? So before I want to run my program and see what happens next, I need to split my data set into two. Okay, I think this is the general procedures for the data analysis. You need to split your data set into two. One would be for training. You want to train your model. You want to train your model in order to get the parameters value. So what would be the parameters values and so on. And then after we train it, we need to apply to the testing data. So we want to test how consistency of the model that you propose in the training data in the testing data. Okay, whether there's a problem of overfitting or underfitting. That is very important because some model they fit very well in the training but fit poorly in the testing. Okay, but definitely there are also some data set fit poorly in both training and testing. We want to have a model that could fit well in both training and testing. The reason why we want the training because we want to train your model. We want to get the parameter values. Some alpha, beta, some parameter exist in the model. Then only we use the same parameter and test the consistency, whether it's good to use or whether there's new data set included, whether they're still performing well or not performing well. So in time series, normally we will set like 70 to 90% of the data set for training. Okay. And also then we will use another 10 to 30% for the testing data. In this example, I will basically using 70% of the data set for training, then the remaining 30% for testing. Okay, this is how I'm used to analyze the data just now. So in this training and testing here, basically you're able to know what would be the best model because you are going to evaluate them looking at the measure of errors, which one is the smallest one. But when it comes to the forecasting, okay, when it comes to forecasting, we are not going to use this data set only or this data set. So for prediction, you're going to use all the data set available, including training and testing for the future prediction. Okay, so this is slightly different from those who have the experience in data science. So for data science, they're going to use like cross validation to train and to test your data set. But for time series, we are not doing that, but we will just 70% for training, 30% for the testing, and then if let's say we identify this is the best, we combine both training and testing, and we train again in order to use for the future prediction. 100% of the data will be used for the future prediction. So this is my research today will be on this data set. So I will use 70% for training and test and 30% for the testing. So as I was saying, I only use these three models only: exponential smoothing, Hawkes method, and autoregressive integrated moving average. Okay, so three models have been used, and you will find that in exponential smoothing, there's one parameter here which try to control the level of the series alpha. Meanwhile, for the Hawkes method, okay, there are two parameters alpha and beta to control the level and trend. So these two methods, autoregressive, there's a lot of unknown parameters. So if you want to know more about ARIMA models, then maybe you need to do some study on how they be used for ARIMA models. So these two actually quite straightforward because they're going to use the formulas given to compute to estimate the level and trend. And for Hawkes method can use for long-term forecast because sometimes some method can only use for short-term forecast. Short-term forecast means that we're only able to use this model to predict maybe tomorrow or maybe 2 days after. That's all. Okay, that's all. That is called as a short-term forecast. Some model they can use for long-term forecast. Long-term forecast means that I can use the same model to predict 10 days after, 20 days after, and so on. If the same component continues in your data set, then I can use for long-term forecast. Meanwhile, Hawkes method and ARIMA model can actually use for long-term forecast. Meanwhile, exponential smoothing is only suitable for short-term forecast. Short-term only. Okay, so this is my coding. This is my coding in R. So I assume every one of you have some understanding on R because this is not an introduction to R programming. So I just share with you how do we write the coding in R. So basically, I just try to make it simple. The first is actually is to read the data file. Okay, the file is saved in the CSV. Okay, comma semi CSV. So there's a header, and this we need to read it. Then we need to present it in the time series data set. So this TS represents the time series data. So it means that I will try to use the variable here. There's two variables in this data set. One is the time, another one is the average growth. So I want to make it as a time series data. And your starting year is 1970. Okay, your starting year is 1970. So then, as mentioned, I'm going to split your data set into two, training and testing data. Okay, so 70% of the data, the first 70% will be used for the training data, and the remaining 30% will use for testing data. Okay, so and then only we do some training, the fitting, so with different models. So I have three models here. One is the ARIMA, one is the simple exposure smoothing, another one is the Hawks method. Okay, so in R is quite straightforward. So basically, you just need to SCS for the simple exposure smoothing, then using the train data set, okay, and give the initial value, then they're able to produce the forecast value. And after that, accuracy here is actually trying to evaluate how good of the model in the testing data. So that's why you see that, okay, the model that you produce here apply in the testing data. This is actually how it works. So I'm going to show you the result for the first two, okay, exposure smoothing and Hawks method. So you can see this is actually the time series plot generated using R. Okay. Okay, so I have fitted the model with the data with two models. One is exposure smoothing and Hawks method. And this is the first 70% of the data set. So generally, you found that the data set actually does not fit well to the observed value. So where the black line here is actually the observed value. So the red color line is actually the forecast value generated by exposure smoothing. The green one is actually the forecast value generated by the Hawks method. And these are the accuracy of the two models in both training and testing. So something that I need to mention here is about the exposure smoothing, especially on the MAP value. This is one of the methods to measure how good of the model to the observed value. So training data actually they produce 5.4769 only. But when we want to use the same model, the same parameter, and apply to testing data, so we found that the error actually has been increased to 13.2810. You can see there's a lot of increase of error compared to training and testing. So this indicates that you have overfitted. Okay, overfitted means that this model performing very, very well in the training. However, when you have new data set coming in, so this model does not fit well to your data set. This indicates that this model does not fit well to your data set being given. Okay, so I mean soon later I will going to reject this model. I will conclude that this model will be out from my list, okay, because there's a problem of overfitting. Now Hawks method is different. You see the difference between all these values, especially MAP. Okay, so training data is get 5.55 and the testing is 3.31. So getting smaller. Okay, so it means that this model actually fits well to the data set. Fits well because it does not have the problem same as the exposure smoothing where the testing data actually the MAP is a lot. But here actually it has been minimized. So 70% of the data set, so this is the error that you produce. But when we apply the same model to the testing data, so these are the measure of forecast error. So compare between exposure smoothing and Hawks method. So this model will be chosen. Since all the measurement, if you compare not only everything, if you compare to Hawks method and exposure smoothing, so all the error actually are comparatively lower to the exposure smoothing. Okay, and this is actually is true, this true model, exposure, smoothing, and Hawkes method. How about ARIMA model? ARIMA model. The ARIMA model actually they need a lot of process. The steps actually is quite a lot. So in order to find the best model, okay, because it's not like the two models that have been proposed earlier. So very straightforward. Okay, these two models. So these are two formulas we're using and produce forecast. But for this ARIMA model, which is quite complicated, so it involves 6 steps. Okay, 6 steps in order to determine whether this model can be used or not in this data set. Starting from stationary, create some plots, then will only be identify the models based on the plot you have, then only do the fitting, then again evaluate the performance. So we need to predict the values and then only to calculate the accuracy. Okay, so I will go through a little bit on this ARIMA model. So if you're interested in this model, definitely you can explore more, okay, or explore more about what is ARIMA model is. Yes, this is actually we are trying to construct. So this is the syntax in R as well, is to display the training, the time series plot and also these two plots. This is actually is the ACF. We call this as ACF and PSCF plots. This is trying to explain the autocorrelations between the observed value. So remember in the first step, we need to know whether it's stationary or not stationary. So from this plot, actually you have found that this is not stationary because we were looking at how this spike actually been occur in the ACF plots. So this spike indicates that the relationship between the data set is remain significant. 2 days ago still significantly affect the prediction today. 3 days ago, 4 days ago, 5 days ago, even though it is far from the today's record, but the effect on the historical data still continue and will affect the study here. Stationary is something like a series that it does not have trend and seasonality. Okay, so this indicates that there's a significant spike, especially in the beginning of 1, 2, 3, 4, 5 legs. So this means that I need to transform it because this indicates that the series is not stationary. Okay, I need to transform it to become stationary. So the way we need to transform the stationary, we call it as differencing. Differencing is actually trying to evaluate the performance, find the differences between today's record and yesterday's record. Then we get the value, the difference value. Then 3 days after and today, then another differencing value. Okay, so when you perform the differences between this record, basically your data set will becomes like this. If let's say has become stationary, so you can see compare left and right. So this is a typical pattern of not stationary series because it remains significant. If this is stationary, so all these values actually is quite we allow to have significant spike at the earlier spike at the earlier legs. This is why time series is important because we always use yesterday record to predict today's record. But when the time increases, so the older data should not be included in prediction because that was very far from us. Therefore, the relationship should be very, very weak when the time trying to move earlier. So that's why the relationship after has to be close to 0. That's the meaning of stationary series. So my apology for not able to explain it well, okay, about the types, about the stationary properties. If you are interested, then you can actually find out more what do we mean by the stationary series. But in this ACF and PSCF plots, you can actually looking at how's the behavior in the earlier legs. Okay, so this is not, we cannot allow to have significant like this. We allow to have one or two, but after that goes to 0. That is okay. That is acceptable, and we still conclude this as stationary. Okay. The typical stationary series is like this, the ACF and PACF plot. Like the first one is significant and immediately drop to 0. Okay, so remember there have two plots being generated. One is ACF, another one is PACF. So these two plots will be used to identify the model. What are the suitable models? So moving average, how do we know? It's actually is looking at the ACF plots. If the ACF plots follow cut-off pattern, cut-off means that the first is significant, then after that drop to 0. Okay, so then drop to 0. But we only allow to have cut-off after leg 1, leg 2. So it means that the first is significant, then after leg 1, after the first one, goes to 0. Meanwhile, PACF then goes down, like exponentially. So it has to follow exponential curve. If you have this pattern, then we know this is the moving average model. Moving average model. Or opposite way. ACF is actually is exponentially pattern. PACF is cut-off pattern. What is cut-off pattern after leg 2 means that the first two are significant, but after leg 2, all goes to 0. Okay, but this happens in your PACF, and this model we call it as autoregressive. So what is the difference between a moving average and autoregressive? Autoregressive will try to use the past observation to produce the forecast value. Meanwhile, for moving average, we're trying to improve the forecast value by taking account the forecast error that you calculated earlier in order to improve the model. So again, AR model actually is we're trying to improve the forecast value by including all the past observation. Okay, 1 day, 2 days ago, 2 days ago, 3 days ago, or others. That is for autoregressive. But for moving average, we're going to improve the forecast value by using the forecast error that you calculated earlier. Then we further improve your forecast error, forecast value. That's actually how the moving average model works. So one is using forecast error, one is all using the past observation. Okay, that's the difference. We also allow to be a mixture of both. So it means that not only using past observation, but also using the forecast error that you calculated earlier to improve the forecast value. That is called as ARIMA, ARMA, ARIMA combined. If looking at the ACF and PACF plot, so if both ACF, PACF exhibit exponential curve, then we are using this model. So remember just now there's one of the curve, one of the plots actually shows cut-off. But let's say both also shows dies down like this exponentially, then it's actually a mixture of both AR plus MA. So I know after go through all this discussion, maybe because of time limit as time constraint as well, so you may feel, oh, so difficult to identify the appropriate ARIMA model. Yes, it's quite difficult and it's quite subjective as well. So that's why in R, right, there's a function, there's a syntax called auto.arima. So this function in R, which is able to compare with different models, different time series, different ARIMA model, which could be generated based on your ACF and PACF plot. So that is actually why R is actually being used, especially in time series, because this function is very powerful, because they're going to list out a lot of ARIMA model, which presented in ARIMA. There are 3 values here. It indicates what are the model, and also indicates the differencing required. AR, as I said, if there's some values in the P, means that this is the AR model. When the AR model, then you know that, oh, this model actually adjusts the value based on the observed value. If there's values in the Q, so it means that you are MA model. MA model means that, oh, you are actually improve the forecast value using the forecast error. And differencing will also be shown in the middle to indicate that whether or not to apply differencing to transform your series from not stationary to stationary. Even me also sometimes will make the wrong interpretation because of the pattern that you have required. Sometimes the nature of the data set is quite complicated because of the noise, because of a lot of reasons. Therefore, we might not able to interpret the model accurately. But with this function, they're able to compare. Okay, we're able to generate and then compare which one is actually the best one. So actually these values are actually generated by using AIC value, tagging information criteria, where this value, how do we know which one is the best? The lower the value, the better the model that we propose. So compare these four. Actually there's a list, they list out a lot, but I only show four here. I'm going to use this one only because the AIC is the smallest, 2.855451 only. That's actually is 100. So it means that for your data set just now, the best model is actually is AR1 here. And this one means that you only use data 1 day before only. If let's say 2 means that you are using 2 days past observation. If let's say they shows that A300 means that you're going to use 3 past observation to produce the forecast for next period. But now in this case is 1, means that your model here is actually only using YT minus 1, which is just using your past observation in 1 day before in order to produce the forecast for next period. Okay, so this is actually why we're using R in most of the time series analysis, because they could fit very well and they could compare and evaluate which one is the best one. Okay, so these are the results given. Now I want to combine the result with the exponential smoothing and Hawk's method. Right, so now all these 3 models combine, and then we also combine and present the results in the time series plot. Okay, so as I mentioned, exponential smoothing will not be considered because of overfitted. Why? Because of NAP value, you see there's a big difference between these two. But same problem when you're using ARIMA model, 5 point something. But when you apply the same model to the testing data, because 42, very, very bad. Okay, the performance was very, very bad compared to other 2. Okay, which means that this model also has been overfitted to your data set because it only works well in the training data. But when we try to use the same model and apply it to the next 30% of the data, does not fit well. Okay, so these 2 will definitely say no from my analysis. No, because their performance is very, very bad. So the model that I'm going to choose here is called Hawk's method. Okay, so from the beginning, I proposed 3. Okay, the proposed 3, and based on the accuracy, I found that exponential smoothing basically there's a problem overfitted. Same goes to the ARIMA model, also have the problem of overfitted. So these 2 models will not be included, will not be considered to produce the forecast for next period. So the model that best fit to your data set, okay, which also works consistently in both training and testing data, which is called as Hawk's method. So therefore, we use this model for the final prediction. For the final prediction, then I will use this model. And for final prediction, I will use all the data set available. So the 70% in training plus the 30% in the testing. Then I produce these results. Okay, so now I'm going to use all my data set available again and do the fitting again using Hawk's method. So I plot the graph and shows the line of the fitted. Okay, and looking at the forecasted value here, so this blue line indicates the forecast value. So you can also look at the right hand side here. These are the forecast value. So generally it shows decreasing, which means that the growth of the population after 2017 actually is still decreasing. It's decreasing over time. Why there's the two gray colors here? Actually, the dark gray here is actually shows the 95% confidence interval. Okay, so the lower and upper limit, and the light gray is actually 80% of the confidence interval. So basically, will be generated automatically. So when you construct the plot for the forecast value, so H equals to 10 because I want to use this model for long-term forecast. It means that I use it for 10. I want to predict 10 years ahead from my last observation. That's why you see there's a 10 data records up to 27. So the forecast values continue to decrease, and these are the lower and upper limit for this data set. Okay, so this is how the forecasting process is. So actually it's quite easier, and okay, if let's say you know the theory and also the model well, so once this data have been given, so we can play around with different model, and then we try to fit how the data set, how's the performance. So at the end of the day, we only use the best model to produce the forecast for the next period. Okay, that's all for today. That's all for my section. Thank you so much.
Thank you. Vote of thanks.
Hello?
Hello, Doctor?
Yes, hello.
Yeah.
I'm here.
Okay. Vote of thanks.
There is a Rija ma'am.
Vote of thanks by.
There is in chat ma'am.
Yeah. So, hello.
Sir, excuse me.
Yes.
Sir, there is a query, sir, through chat. What are the main advantages of ARIMA and artificial neural network?
What is the main
advantages of? Hello, sir, can you hear me?
Yes, I can.
Advantages of ARIMA and artificial neural network.
In time series, you mean? You mean in general or just for time series analysis?
Hello. Artificial neural network, sir.
Oh, artificial network. Okay, artificial neural network can also be applied in time series. Definitely, the performance could be fit well, okay, better than the model that we discussed here. Okay, so artificial intelligence also can use in time series data. So the reason why we want to, because the accuracy will keep on changing. They definitely will prefer to have the model which able to produce a very good forecast value. So here I just demonstrate some basic model, okay, for forecasting. Actually, as I say, artificial intelligence also one of the models that can be used for forecasting. So definitely when you're able to train your data set well, then the forecast value given will be very much better than the model that I propose here. But that one you need to go through some processes to train your data, check the accuracy, and so on. But the process are exactly the same. Maybe you can just propose one more for neural network, and then we compare which one is the best. But in time series doesn't mean that the advanced model is always the best. Remember, in organization, they want to use a simple model, and the performance is better. So in this data set, I would say ARIMA model is actually one of the advanced time series model. However, when in this data set, Hawk's method, which is a simple model, which actually can fit better than the ARIMA model. So it doesn't mean that always the machine learning or the advanced model fit well to the data set. So it has to look at the whole nature of your data set in order to make a decision.
Okay, sir, thank you. And another question is there. Without R programming, can we use ARIMA model to fit the data?
Without using R, you can
program.
So if you are good in Python, definitely you can use Python. If you feel like you're not familiar with the programming language, you can use SPSS. Okay, SPSS, yes, they also have this function they can use. SPSS also, they're able to compare different ARIMA models. They will try to fit different ARIMA models and propose the best for you. But to be honest, even though I'm using R to generate, But at the end, I always need to match with the data set, the behavior of the data in the plot. Because sometimes they will propose wrong model or incorrect model. So your understanding to your data set is very important. Your interpretation to the ACF and PSCF plot has to be very strong, because the model that you propose, which is different from what been given by SPSS or R, sometimes your model is better than those who given. But you can use SPSS as one of the method, one of the software to conduct the time series analysis. Yes.
Okay, sir. Thank you.
Yeah. I hope I can answer your question.
Any other queries are there? Ma'am, shall we go for vote of thanks?
Yes, yes.
I think there's one question here is about if the data is overfitted, is there any method to underfit that? Okay, so regarding to this question, actually, if you are underfitted, normally we are not going to use this model. We're trying to consider other models. Okay, so let's see how the performance will be. So that it have overcome the problem of overfitted or underfitted. Underfitted means that works poorly in both training and testing. So that is something that we're trying to avoid. So we really want to have one model work consistently in both training and testing. So if you're not, then you might consider another model that could fit well to your data set. Yeah.
Okay, sir.
Any limitation of using R? I think this has some argument between R and Python since a long time ago. I have no answer for this any limitation of R programming because all the while I'm using R in different analysis, including regression analysis, time series, and operational research and others. Okay, I'm all using it. Okay, but I'm still prefer to use R again. No answer. I have no answer for the limitation of R, but there's a lot of arguments between R and Python. So it depends on you which one you prefer. Yeah. Like from the Dr. Mitra. Any other question?
Nothing.
Okay, no.
Girija
Okay.
ma'am?
No any questions. Shall we move for the vote of
Okay,
thanks?
Girija ma'am, shall we
Sir?
wind up?
Yes, yeah.
Yeah. Okay, it gives me pleasure in proposing vote of thanks. First of all, I would like to thank our management, higher authorities to support us for conducting this faculty development program. Next, I would like to thank Dr. Ho Ming Kang for his excellent speech on analyzing time series data using R. It's very nice to have you here in our FDP, sir, and to have the benefits of enriched knowledge shared by you in spite of your busy schedule. Thank you, sir.
Thank you so much. Thank you so much.
To Dr. KP Buma, HOD of our department, for her consistent support. Also, I thank our colleagues and participants to make this session a successful one. And special mention to Ms. Varsha, who is working and providing technical support for us. Once again, thank you all. Thank you.
Okay, thank you so much,
Thank you,
everyone.
Doctor.
Thank you. So everyone take care and looking forward to see you guys soon.
Oh, yeah.
Okay, bye-bye.
Bye.
Bye-bye.
Thank you.
Bye-bye. Thank you.
You may leave. Yeah. Padma,
Ma'am?
so it will be open up to 2 o'clock now.
Yes, ma'am. I've already sent the message. They can send the
Yeah.
feedback till 2 o'clock.
Till 2 o'clock.
Yes.
Okay. So Varsha will look after that, no? It will be open. Is it not? ఏమ్మా పిహెచ్డి లో బయోటెక్నాలజీ ఉందా? పిహెచ్డి లో బయోటెక్నాలజీ ఉంది. స్నేహ